Hello, and welcome to the Western Digital AI Data Cycle launch. I'm Rob Soderberry, Executive Vice President and General Manager of the Flash business here at WD. I'll be joined today by Ravi Pendicante, Senior Vice President of Product Management for our HDD business. Today, we're going to be introducing the AI Data Cycle, and we're going to share with you a set of product, technology, and roadmap announcements in support of that AI Data Cycle. AI is everywhere today, and today we'll share with you what the impact of AI is on storage, and in turn, the impact of storage on AI. So let's get started. AI is everywhere today. And behind that AI, there's a tremendous amount of investment in infrastructure to support all these new wonderful applications. We've all heard about the work that's going on in GPUs and compute, as well as in high-performance DRAM, or the HBM DRAM. They're coupled so tightly with those GPUs. Today, we're going to drill into the third pillar of AI, which is storage, because storage is becoming increasingly critical for AI, and in turn, AI is becoming critical for storage. Today, we're announcing the AI Data Cycle. The AI Data Cycle illustrates how storage is consumed in the process of training AI, data consumption, and then as data is generated, storage is used to store the output of that AI. We call it a data cycle because essentially it's a continuous cycle. Data feeding the AI for better and better results, and then producing new data, which is then fed back into that AI architecture. It's a virtuous cycle. Now, as we unpack that AI data cycle, it's important to understand what an AI data center looks like. You might have a simple idea, the GPU, running some training, then being used for inference. But AI data centers operate at a massive scale. This is industrial AI, multiple data centers, even multiple geographies. So with the AI data cycle, we've essentially unpacked that and showing each of the stages of feeding data into the AI pipeline and then production of data out of the AI pipeline. I'm going to go through each of those stages now. The first stage is that raw data archive. As we all know, the more data, the better your AI. All that data has to be stored somewhere, and typically that's in very high capacity object stores. These are serving as the holding tank for that data, archival copies of that data. From that archival, we can move on to the next stage of the data pipeline. This next stage of the pipeline is where the data is prepared and ingested into the AI supercomputer itself. In the database era, we would have talked about this as ETL, or extract, transform, and load. In the case of AI, though, we're performing a lot of complex operations here that demand a lot of performance as we turn that raw data into information that our AI models can consume. This is things like vectorization of the text and the images and videos and all the content that's going into that AI model. This is starting to become a more demanding part of the pipeline with tremendous both compute and storage infrastructure requirements. Then we go to stage 3. Stage 3 is where the magic happens. The AI model itself is trained. We've taken our raw data, we've transformed it, we've readied, and now we're feeding that into that GPU and DRAM complex at the heart of AI training. What's important here is that we have an enormously costly, enormously expensive infrastructure we put in place to do that AI training. And we want to make sure that we don't run that pipeline dry. And so the performance and the feeding and the care and feeding of that GPU complex is extremely, extremely critical. So in stage 3, we're feeding those GPUs, training that model. Now we move on to the next phase, which is interface and prompting. Here's where the user gets involved, typically working interactively with the AI model to write prompt to produce the outputs they're looking for. They're continually iterating and working through the inference process to generate that output. The infrastructure requirements here are those of a normal enterprise application, the compute, the storage, the services, either supporting the user interface or the API, depending on the application. Then it's on to the AI inference engine itself. Now, this inference engine could be running in the data center in a very high performance compute infrastructure, or it could be running out at the edge on your mobile device or your client device. But this is where the AI model is actually running to produce the content, the new data that user or that programmatic interface is driving towards. And finally, all that results in new content generation. And this is the amazing thing about AI. The rate, the type, the quantity of content that can be produced is just astounding. That content is getting stored on those local devices in the data center, it's getting distributed, it's getting copied. We're seeing a virtual explosion of content as an output of the AI process. So there it is, the 6 stages of the AI data lifecycle. Each of these stages is unique. Different infrastructure requirements, different compute requirements, different storage requirements, different activities taking place. But each one is important to this overall AI data cycle. Now we're going to dive in and talk about some of the details of what this means for storage. So let's go back and look at each of these stages and what the storage requirements are. We'll start with content. Content storage, this is the mass and mass storage, typically provided by enterprise capacity HDDs. Enterprise capacity HDDs are wonderful for deep content repositories, and it's where the world's information is kept. Then we move to that stage 2, where the data preparation and transformation is underway. This becomes a very compute-intensive stage, and so we now move from HDD to SSD. And specifically, we're using high-capacity enterprise SSDs. These allow us to build very high-performance object stores and data lakes, which essentially are the pools of data that the extraction engines, transformation engines can work on top of. From there, we move into this chain of training all the way through inference. From a data center perspective, this is all extremely demanding workloads. So we shift gears again. Now we're using very high performance, lower capacity, compute-oriented enterprise SSDs. And here are really the premiums on performance. That very expensive GPU complex, you don't want that to run dry, so we want the fastest possible drives. In addition, in this process, there's a lot of complex operations, checkpointing, archive, and so on, that may take all that entire data set and flush it back into your data lake or retrieve it depending on the status of your computation. So you'll see a mix of compute drives as well as use of your data lake. Now, when it moves to inference and beyond, that's where our paths separate here. From a data center perspective, it's that same compute infrastructure, but on the endpoint, on the client, now we're talking about mobile devices, client devices, IoT devices, and this is where inference is actually happening out on the edge. There's both a performance requirement there, in that inference is quite demanding, and also a capacity requirement in the production of new data. And so you'll see demands on client drives, performance and capacity-oriented client drives filling that need. And then ultimately, where does that content go? That content goes back into our long-term content storage, archives, and really back into the HDD world, where all of our long-term content is stored. Now, at each of these stages, demand is increasing, and it's increasing significantly. Let's dive in and look at the nature of that. Let's take a look at the capacity required by the AI data cycle. We'll start in the data center. We're going to need both incremental HDD as well as enterprise SSDs. Now, we've built a proprietary model that looks like the total capacity required for that archival storage, for the prep and ingest phase, as well as for the compute phases, and then ultimately content storage again. What that model tells us is growth in both HDD and enterprise SSD. On the HDD front, over 20% growth in the enterprise capacity HDD drives. While for the enterprise SSD drives, 30 to 40% growth split between the high capacity data lake oriented storage and the high performance compute drives. So tremendous increase in the data center. So now let's turn to the client side. Here in the client, both in the mobile as well as in the PC market, we're seeing the introduction of AI-ready and AI-powered PCs and mobile devices. These devices are more demanding, so performance is a premium, and they're more capacity intensive, and so they're demanding larger drives. In the corporate world, we're seeing people move from a 256 gig drive up to 512, while in the mobile world, there's pressure on the 64 and 128 gig phones to move up a full capacity tier. Together, these drive big numbers, 40 to 50% increase in mobile smartphone flash demand, and 25 to 35% increase in client SSD demand, for the PC and laptop market. Then, weighted storage propensity, which is just how much data is required to train AI models depending on the type of data you're training on. For example, it's relatively straightforward to train on text, but as you move up to audio, to images, and ultimately to video, you have exponential growth. Hundreds of times more data, thousands of times more data in the case of video. So you can see very, very quickly how the storage demands can tremendously escalate. Data volume is simply the total amount of data that's created from all digital sources, data centers, users, devices, and so on. And data volume continues to increase over time, growing at well over 20%. By 2028, the total amount of data produced on an annual basis will be nearly 400 zettabytes. Now, to give you an idea, today, we only store 1 to 2% of that data volume. But there's virtually no limit here. AI is increasingly making use of all that data in new ways, motivating people to store it, and of course, contributing to the creation of that data volume. So there's plenty of demand here for more data to be stored and more storage devices on which to place that data. So that is the AI data cycle. We've talked about what the cycle is, the requirements of each step of the cycle, and the capacity and volume of data that's being driven. And the big news here is that storage is driving AI and AI is driving storage. Now we're going to turn our attention to Western Digital's leadership in AI in support of the AI data cycle. Announcements of product, technology, and roadmap updates featuring Western Digital's AI-ready technologies. First up is HDD, where you're going to hear from Ravi Pendakanti.
As Rob mentioned, we see an incredible amount of growth in storage on the horizon. And this especially applies to HDDs as they bookend the AI data cycle. The value of stored data is only going to increase as AI models become even more capable, ingesting deeper levels of historical data and creating even more new data for analysis. With all this data comes the need to store more data for even longer periods of time. Of course, this is where hard drives shine, specifically those at the highest capacity points per drive, enabling the largest cloud and storage providers to maximize and scale their data center build-outs to meet their ever-growing total capacity requirements. Our industry-leading HDD storage technology, UltraSMR, offers the highest capacity point available at scale. Alongside our EPMR and OptiMan technologies, and soon our HAMR offerings, our predictable portfolio puts our customers in the best position to meet AI's increasing demand for storage today and well into the future. Speaking of meeting today's needs for storage due to AI, I'm excited to announce that not only are we shipping the high-capacity 28 terabyte drives in volume today, but we are also sampling the industry's highest capacity at 32 terabytes with select customers, representing an incredible increase in drive capacity for hyperscale cloud and enterprise data centers. This new 32 terabyte drive boasts more than a 13% increase in capacity over our latest HDD and is built on proven designs from generations of our other highly successful products. With this, our customers can expect seamless qualifications and integrations for rapid deployment, all while maintaining the superior dependability and reliability they expect from Western Digital. We will share more details on this 32 terabyte generation of HDDs later this summer, so stay tuned. Giving our customers the ability to store more data today at scale enables them to capture this increasing value of data for their AI workflows. Even more so, we're delivering the most innovative storage technologies at the best possible total cost of ownership value to enable our customers to meet the new demands of the AI data cycle. And of course, our roadmap doesn't end with UltraSMR. As you may recall, we shared a very similar version of our roadmap with you a few years ago. Clearly, we're in the 30 plus terabyte range today, and in a few years, we'll be in the 50 plus terabyte range. Beyond that, we will be in the 100 plus terabyte range. Our predictable capacity leadership strategy is core to the value we bring to our customers. This is why we believe we're in the best position to deliver the highest capacity HDDs across all recording technologies and TCO values today and well into the future. It's also why we believe our highest capacity, most reliable HDDs will serve as the backbone to the AI data cycle's ultimate success in the real world. With that, we'll get Rob back again.
Now let's turn our attention to the flash announcements. First up is a new ultra-high capacity enterprise SSD drive. Today, we're in market with 8 and 16 terabyte storage optimized drives. This drive moves those capacity points to 32 and 64 terabytes, optimized for that high performance storage requirement of stage 2 of the AI data lifecycle. The high performance data lake, the high performance eSSD based object storage. It's a PCI Gen 4 device with all the software features and capabilities required to serve that AI use case. We're excited about shipping this device later this year. Next, we have a surprise for you. Western Digital is proud to announce the world's highest performance PCI Gen 5 drive, purpose-built for the AI data center. This is the drive optimized for stage 3, 4, and 5 of the AI data cycle, the core of AI training, of prompting, and of AI inference in the data center. Market-leading random read performance, PCI Gen 5, advanced software support, features like FDP. We're extremely pleased to report this is already sampled to major hyperscaler and in qualification now for delivery later this year. So those are amazing drives, but we're not stopping there. We see AI pushing both performance and capacity moving forward. In fact, we'll give you a little of a sneak peek of what we plan on the capacity front. So today we announced 32 and 64 terabyte drives for availability in 2024. Next step, 128 terabyte for delivery in 25, 256 terabyte for delivery in 27, and on our long-term roadmap, a 1 petabyte drive. So we think we've got capacity covered in the AI data cycle. So that's the new AI data center portfolio. Now let's turn our attention to client. So what's happening at the client? Well, AI is being used in all kinds of creative ways. Office productivity, creators, video, gaming. The sky's the limit when it comes to client-side AI applications that we're going to see on mobile as well as in PCs. They're driving the same requirements, more performance and more capacity. And that's why we're pleased to announce new releases on our WD Black as well as WD Blue client drives, offering 4 and 8 terabyte capacity with our high performance WD Black drive, as well as our WD Blue line of client SSD drives. So there you have it, a suite of new products and technologies in support of the AI data cycle. But the AI data cycle itself is the real news here. In Western Digital, we're pleased to share our insights on storage's impact on AI and AI's impact on storage, and deliver these wonderful products and technologies to enable everyone to unleash the power of AI. Thank you for joining us.